Flat earther, astronomer, and hobby astrophysicist Wakey recently decided to ask some questions to well-known physicist Brian Cox. This guy. Apparently, Brian Cox had an Ask Me Anything session on Reddit. Wakey posted these 5 questions on Reddit, where another Reddit user set Brian Cox up to troll Wakey by asking the question, "In all your years as a professor, what was the most ridiculous, nonsensical theory you've heard about?" Where Brian Cox's answer, of course, was flat Earth. That, and the fact that Wakey his comments were removed from the Reddit, apparently pissed him off to a point that he made a video to rant about it. In the end, he even resorts to insults. He refers to Brian Cox as Brian Sucks Cox and calls him an asexual who is selling his soul for money. The childish behavior and the nature of his questions kinda make me wonder if Wakey actually is an astronomer. But, I don't think it takes an astronomer or a physicist to answer his 5 questions. Question 1. How can there be a vacuum next to a spinning atmosphere without a barrier? Actually, I think Mr. Thrive and Survive would be able to answer this question. Mr. Thrive and Survive used to be a meteorologist in the US Navy, if I'm not mistaken. The difference between a vacuum and a non-vacuum is pressure, basically. The only thing is, the vacuum has an absence of a gas with a certain density. However, the difference in pressure is something we see within our own atmosphere as well. This is a weather map of the USA, where you see a high pressure area and a low pressure area. There is no barrier in between. The high air pressure is more dense because it's colder. The low pressure area is less dense because the air is warmer. The pressure wants to even out, causing wind. There is no barrier between the vacuum and the atmosphere because the vacuum doesn't suck. It doesn't apply force. It is merely a lack of substance. Earth has gravity, pulling the molecules in the air. Close to the surface there are many molecules, so the pressure is high, and the higher you get above this surface, the less molecules there are and the lower the pressure is, until there are no molecules and no pressure. This happens without a barrier. Question 2. How high is where the spinning atmosphere turns into a vacuum? Well, as explained earlier, this happens gradually. The more you gain altitude above the surface, the air pressure fades more and more, up to a point that there is no air pressure. The thermosphere starts at about 90 kilometers above the Earth. Above that you have the exosphere. The exosphere could reach up to about 190,000 kilometers above the Earth's surface. The near vacuum starts somewhere between the thermosphere and the exosphere. Question 3. How did they build the ISS moving at 170,000 miles per hour? Well, this is actually quite simple. Buy a box of Legos, get in a car, sit in the passenger seat, and have a driver accelerate the car to 100 miles per hour. Build your Lego toy. How did you build the Lego toy whilst moving at 100 miles per hour? I'm going out on a limb here and say it was only possible because you and all the Lego pieces were moving at the same speed without the air resistance applied to you and the Lego. Question 4. How do thrusters work in a vacuum? Well, like this. Rocket fuel is a multi-component fuel. It has its own oxygen. They might even carry liquid oxygen in order to burn. The expansion of the gases in the combustion chamber does create thrust, even in a near vacuum. Question 5. Gravity bends oceans, yet I can lift water out with my hands and splash it. Well, yes, of course, because you are not lifting the entire ocean. The ocean isn't one object, it is a rather large collection of hydrogen and oxygen molecules, and when you splash the water, that is only a teeny tiny part of the ocean. and the force you apply on that teeny tiny piece of the ocean is far greater than gravity. Gravity in general is measured to be about 9.8 meters per second squared, which is an equivalent of newtons per kilogram. You apply 1 newton of force to accelerate an object of 1 kilogram to 1 meter per second, meaning your muscle power is easily more forceful than gravity. For example, when you jump, you temporarily exceed the force of gravity to the point that the upward energy you have applied has dissipated due to friction, drag, and gravity counteracting upon it. After which, the constant force of gravity pulls you in again, and friction and drag slow your fall. These are my 5 answers to these questions, but I'm no physicist, so anyway, is a physicist necessary to provide a good answer to these questions? Or was Brian Cox correct when he chose to ignore wakey wakey? Let me know in the comments, and thanks for watching.